So yeah, so the divergence of v, well, the problem is that the source of the function or the problem is at r is equal to 0. We can see that the function is 1 over r square. So if you put r equal to 0, so this blows up, and that's the very important point in this problem. So the divergence of v is actually 0. Divergence of v is 0 everywhere except at r equal to 0. At r is equal to 0, actually this has the maximum divergence, and you will see later. So this kind of property of a function which is 0 always, which is 0 everywhere, but has non-zero value at a single point, this kind of function in mathematics is known as a delta function. We call this dirac delta function. I mean, divergence of p is not Dirac delta function, but it involves Dirac delta function, and we will see later that how we can write divergence of v in terms of delta function. So Dirac delta function is actually a function which is 0 everywhere except at a single point where it's not defined actually. So in that sense, delta function is not a true mathematical function, but we can say that it's a generalized function or kind of distribution. So let's come to the one dimension Dirac function. So I will straight go to the definition of delta function. Write the definition of delta function. For one dimension, we write this del x because x is a single coordinate, so it's for one dimension. And this function has two values. It's 0 when x is not equal to 0, and it's infinity when if x is equal to 0. So it's undefined at the origin actually on the coordinate system, of the one-dimensional coordinate system. And another property is that if you integrate delta function from minus infinity to plus infinity, so you will obtain 1. So this is the property of delta function. If you want to represent delta function, for example, in the form of a graph, then you can draw like this. Let's say this is x-axis, and this is del x. So we can plot delta function that it's 0, this is origin, so it is 0, and when you come close to the x is equal to 0, it blows up, and then when you cross it again come to 0. Yeah, and the area under this curve is then equal to area under the curve is equal to 1. So you can represent like this. So delta function is has a spike at the at one point. So since the delta function is undefined at x is equal to 0, so it's not a true mathematical function, because you know the definition of function, that function is always has a unique value at every point of the domain. but here it's not the case. At x is equal to 0 it has it's not defined, so it's not a true function. Rather it's a generalized mathematical function or a distribution, not a true function. It's a generalized function or distribution. Yeah. Coming to the other properties of the delta function, that sorry, let me in this show to add another slide. Let's see. For an ordinary, so for an ordinary function f of x, which is not a delta function, yeah, so this is another slide, so I will have to make this clear. Yeah, so f of x was another function which is not a delta function, and if you multiply with a delta function, then this will be f of 0 del x, and I hope you understand why this is the case, because you know that del x is 0 everywhere. I mean, if you draw, for example, this plot again for the delta function, and this delta function, and if you place another function, for example f of x, any random function, and you multiply, so you can see the delta function is 0 everywhere except at x is equal to 0. So f of x is not non-zero, away from the x is equal to 0 position, but since del x is 0, so the product will be 0, and at x is equal to 0, f of x is not equal to 0, but delta function has some value, and then you will obtain only this value. So that's how you can you can understand this. So if you integrate both sides, f of x del x dx from minus infinity to plus infinity, minus infinity to plus infinity, f of 0 del x dx, so you will obtain f of 0 minus plus f of x dx. I'm sorry, this is not f of x, this is del x, so this will be 1. So this is 1, this is 1, so you will obtain f of 0 only. So this is very simple. Just to clear one point, that the limit of integration from minus infinity to plus infinity, it's not important. I mean, you can take some other range of this domain, but the important thing is that the domain should include the spike of the delta function. Important. Minus infinity to plus infinity is not necessary. We can take minus epsilon, a small number, to plus epsilon, so that it extend across the delta function. So I will stop here and we'll go to another video.